Hello everyone, my name is Jarice II, and I was fortunate enough to work under the game-changing development program at Langley Research Center. I'm from Mathematics Regional Government School, and my mentor was Mary Beth Was. To give a quick outline, I'll be doing a quick introduction and mission walkthrough, telling you what I was assigned, the application that I created. I'll step through that with you all, and then conclude and then end with questions. I don't know if everybody or anyone in here knows what game-changing development does, but basically their main objective is the Space Technology and Mission Directorate. And basically what that is that they take the up-and-coming technologies with a TRL, which is a technology readiness level between 3 and 5, and they basically innovate those and take them a step forward. An example would be the Robonaut. They were the program to actually give the Robonaut legs and make it the Robonaut 2. They've taken things such as the RV3, which is the inflatable heat shield, and that's another thing that they started with. And then, so my actual mission was to create a launch simulation for the mission control aspect of it. You may be asking, like, why do we want to have a mission control launch simulation? Well, it's actually a pretty cool system they have going, and the point of this was actually to help educate and inspire high school students and students below that grade level to actually be more interested in the aerospace industry in that aspect. Also, this would be the first time that this system would ever be done before. Usually, most rocket simulations jump straight to the actual building of the rocket, but no one ever sees what's going on inside of mission control. So just to walk through the mission. So my goals were to after meeting with my mentor Mary Beth, this was the second week. It was like a Tuesday. And I hadn't seen Mary Beth because she was at Wallops that previous week, so I was stressing, trying to figure out when I was going to be able to start my project. But after meeting her, she basically told me that I would need to complete a market analysis telling what is actually together already in the market for the simulations, determine a platform that would be best used for the simulation, review the RV2 and 3, which is something that game-changing development works with closely, and meet with the Wallops Flight Facility team members, and then create a program that can basically be passed on to another individual. So my personal objectives were to create the basis for an educational system, create a structure that can be used and then applied later for someone else to use. So some criteria: it had to be educational, it had to be able to support up to 10 students, and it had to be easy to use to be able to integrate into high schools around the country. And the tricky part is this, able to support up to 10 students. So I found myself coming into this having a good background in programming and technology as a whole, but I have never actually created a system that would have to work over a network, and that's something that this would have to do, because you can't have 10 people at a laptop trying to play a game at once, because that just wouldn't work. And some constraints were time, because I don't think really anyone could create a launch simulation in 4 weeks, well, not even 4 weeks, in 2 weeks, and actually have something to show. Resources were a big problem. A lot of the project would have been easier if I could have had more high-level resources to use to actually just grab assets and just imply into the process. And then the restrictions: NASA has a nice old firewall that doesn't let you just run over the network whenever you want. But to help the Lights program, they got me all over that, and we were able to create servers to help me continue my process. So the programs I used the Unity program, so that was where I did the 3D modeling for the computers, the people that would be in the viewing angle for the players. Also used their web player. This was my first time actually using their web player. It was really, really difficult, but I had to push through it. HTML5 something, it's a pretty simple programming, but it's actually really strong once you combine it with JavaScript and CSS. And then the Node.js is a program that actually allows individuals to connect with each other over networks. So that's something that I was foreign to, but I had to get used to it to be able to create this. And then so for the market analysis, this is for the Play Store, applications for phones. So we have Space Team, which some of you may have heard of, which is where you usually have 2 to 4 or even greater number of players. And so you're in space and your spaceship is going through hectic things. And the only way to basically succeed is that you have to be able to scream and yell at the other players and tell them what you need done. You might need to turn down the booster, so you have to scream over, somebody has to tap something, or everybody has to flip their phones to get through a wormhole. And then we have things like space agency, where all you did was create a rocket and then send it to the sky. You went through suborbital, you did research. And then we have the VR Space Mission Moon Explorer, which is a lot like space agency and things for a simple rocket. But something that all four of these did not have, which is the mission control, like actually seeing what's going on in range control as these things are going on. And then to continue the market analysis, this is for PC games. So we have the Kerbal Space Program, which is maybe a lot of people might have heard of. And Kerbal is actually a very, very strong and powerful program, although they also do not have a mission control aspect, which is where they don't have Kerbals in mission control launching the rocket. It's just them building a rocket and then going up and hoping that you don't crash. And then it's they also have NASA, definitely has a lot of rocket building simulators, but still none of them had what we were looking for. So I'm going to do a quick video just to show what it all looks like. So this is from the Kennedy Space Center, the Apollo mission. So right now, this is, I believe, the test director speaking to the other individuals. We have launch pad managers, range safety officers, the program officers, the experiment managers that actually have payloads on the rocket right now. And everyone is live streaming in, everybody is on telecoms trying to communicate with each other. And it becomes a hectic process to try to re-simulate into one screen, because they usually have about 2 to 3 screens in front of them showing all of that information. So I'm going to skip to the last minutes right before the launch. So you get T-minus 15, 14, 12, 10, 9, and then it launches. So that's hopefully the end product, is that once the students go through the system, then they will be able to launch a rocket, or if not, crash the rocket. So to think about what is needed for a program such as this, you'll have to have something that for each student to be able to choose a job. If it be test director, project manager, mission manager, and you also will need to compose real life data to show like if the pressure in the vehicle of the rocket is increasing, or if the temperature around, or the weather. You also need to be able to create a learning situation for the students. You don't want them to be bored at the computer. They need to be able to always be able to do something. And then also, Mary Beth asked me to actually create a formal communication protocol so that students aren't able to just scream. They actually have to address one another by their job name. So that's another thing to make it a real life situation. And then to step through the application. So starting the mission, each student basically will select a position, and then after selecting the position, it'll come to where it shows what their goals were or what their objective is. So for a launch pad manager, which is the one we're going to shadow today, he oversees all activities basically on the launch pad. He reviews countdowns to decide all pad operations, and then he also ensures that all of the test director, project manager, and mission manager have the equipment and that is present on the vehicle. And then, so this is what the first person view would be. So here you have the launch pad, or where the rocket is, and this would be a live feed. And then you have so something else that a launch pad manager might want to know is the weather report, what's coming in, what's going out. And then we have the PCM, which is the pulse code modulator, which is converts all analog data to digital, and actually shows how the information is being output and letting you know what systems are hectic or what systems are normal. And this is exactly where the game happens. So as the system actually runs, you'll have numbers flowing down the computer, but you have to be able to watch these numbers closely, because if there's an increased rating, like radiation on the vehicle or the temperature on the rockets, you'll need to be able to communicate to the test director or the project manager that something is going wrong and we need to fix it now. And then this is also right here to the right. It's something that I found interesting. Most jobs inside of the mission control, they actually have the terminal count laid out in front of them on paper. It's not on their computers. And so I just thought that it'd be cool to have it on there so each student will be able to scroll through to be able to make sure they're 2 steps ahead while they're working on this. And then so the players will need to communicate. So I also created, with the help of the Lights program, a network basically that each job would log into. And if everything is going okay, then they will be in the green. But if not, they'll be in the red. And that'll be a way for the mission manager or test director to know how everyone's system is going, because they're not able to check in on each and every person because they also have their own jobs to do. And then so as the clock is ticking, it's another way to like get the brain going is to actually create events. So what if a boat floats in? It's like T-minus 10 seconds. It's 10, 9, and then somebody spots a boat. It's somebody's job to be able to say, do we launch it or do we have to cancel and just wait? And that's a decision that they will have to make, and most of them will say, no, we have to stop it. But it's come to find out that you can actually still launch a rocket even if a boat is floating in. Of course, it's safety hazards, but NASA actually goes through protocols to make sure that there are no like any vehicles around. So if a civilian were to float in after the test, then that's something that they would not be able to control. And then so if like 2 aircrafts were to fly in right when they're about to launch also, that's something that you won't be able to launch, because then you have someone just basically ruining your launch and there's nothing you can do about it. But of course, those pilots probably would lose their licenses because they're not supposed to do that. Or just like even something as simple as a thunderstorm rapidly approaching and no one saw it coming, and out of nowhere it's an upward current that just takes out everything. So it's just like creating these certain events that would have the student thinking throughout the project is something that is really important. And then so from problems that I approached was the design issues. Even with my experience in coding, I found like a lot of walls and how I was going to be able to actually connect each player for them to be able to communicate with each other. There's also like problems with NASA's firewall, that nice thing that doesn't let you do anything basically until you get the proper permission. So that actually took like about a week for me to get the necessary equipment to be able to walk over that. And then so this is basically the end of the program. We'll either have success, where is
10,
the
9, 8, 7, 6,
this is the Irby 3.
5, 4, 3, 2, 1, 0. And we have listed off of the Grant 11 carrying
Exactly. And everybody in the room cheers, they launched the rocket. But then there's also going to be that moment in time where somebody misses a number flash across their screen, or they just didn't make the right call throughout the process, and then you have things such as this. Oh, NASA took me down. So that's basically a video of a rocket's failure. And so, I mean, even though they didn't succeed, it's also a succeed that they also succeed in a way that they learned what to do in the moment. Because I mean, you make decisions, you learn from every mistake. You learn way more from mistakes than you do from accomplishing everything. So this is something that helps them, like when they go back at it, what they could have done correctly to actually be able to launch the rocket next time. So in conclusion, was this project a success? I would say so, because I actually was able to create the basis for a project that can be lifted onto someone else's shoulder, and they should be able to finish it with no problem. So you may be asking, so where do we go from here? You've already done everything, so of course it's somebody else's project. Well, there's also the possibility of creating a project like this after you've created it for such a high level of education. It's funny because when I went to Wallops 2 weeks ago with Becky and Mr. Austin, me and Mr. Austin, I was talking to him and I was like, I don't know what I'm going to do. I have no idea how I'm going to do this. He's like, so why don't you just make it for like a grade schooler? Just start out with pictures and then turn those pictures into words. And I was like, that's genius. Why don't I do that? Why not think of that? So now, after creating all of the words for a program like this, you can definitely implement this into like a middle school or an elementary school where they're clicking images the entire time and just learning this basics of how to launch a rocket from the inside. And then so lessons learned, time management is a big thing. Dedication, being able to know like that this is my project and I'm going to finish it. Communication, networking, meeting every and anyone, because you never know who can help you one day. So being able to put your name out there is a humongous thing. And then using the resources around you. It's not great to always complain about what you don't have, but just take advantage of what you do have. And then to have fun. I know me personally, like I got to take a tour with my mentor's husband. He took me on a tour of the hangar. I got to take pictures of OB-10, Cessnas, everything. And then we also got to go over to see Orion. We got to see, this picture right here is actually me at Wallops. I'm in the VIP area where they watch the mission, where they watch from the inside from Mission Control. And then this is at Wallops also. They had a RockSat program going on where they launched the rocket. So I got to take a picture of the rocket, which is really cool. And then, so, questions? Yes.
Could you implement this in coordination with, say, another program, such as Kerbal Space Program or something?
Oh, yes, definitely. So that's the beautiful thing about things like this. Programs are always looking for plugins. And so basically it's a mod. So it'll be that you download this mod, and from there, you would assign each Kerbal a job, let's say. And then that Kerbal would basically pursue those tasks. But that's something that you also have to walk through with them. So instead of being one person, you'll have to be like 10 at a time. And each person has their own subsystem. So you have to worry about those systems. So it's like, it'll be a big task, but that's something I believe that Kerbal would look forward to because they love challenging their players. Any other questions?
Careers. What kinds of careers are you looking at?
So I aspire to be an aerospace engineer. I hope to do a double major in aerospace and mechanical engineering with a minor in material science. Material science, you might be asking about material science. I've actually done an internship at Norfolk State for the past 2 years where we work with nanotechnologies, and I've found all of that very, very interesting. So that's something I would definitely love to see implemented at something called, such as Langley. So yeah, I don't know if I want to become a researcher or an engineer. I'm on the fence about that, but either one would be an amazing experience.
You could be both.
Yeah. What's the one thing, of all of the things that you did, what's the one thing that you're going to take with you as you leave here as that aha moment for you?
Aha moment. Okay. I got to get into assessment, which was really cool. I don't know if that's my aha moment though. I don't know, all of it was just like everything. I go around the corner and I see Isaac like just moving around. I was like, like everything was like breathtaking. So I mean, I say this entire experience is an aha moment. That's, yeah. Yes.
Hey, sorry, I'm not Mary Beth, but I did help Jarice a little bit these last 4 weeks. Sorry for the casualness. She had a diet competition. I came straight from it to try to catch this presentation. But we just wanted to thank you, Jarice, for your contribution. And he's right, for a 4-week stint, what we asked him to do was well beyond that time frame, and he's made significant progress. And pretty much above and beyond what we had expected and hoped. So we are very appreciative to your contribution, and hopefully we'll be able to work with you again in the future. Good luck, and we all wish you well. So I just wanted to thank you all for allowing Jarice to work with us.
Okay, so after that, I'd like to give my special thanks to everyone at the Game Changer Development. So my mentor, Mary Beth, was, here we have in the back Monica Hughes. Her husband also helped me a lot, Stephen Hughes. He actually helped me a lot with actually gathering the information to actually create things for like the pulse code modulator and the terminal counts. Rebecca Ernest, she was the first person to like introduce herself to me because pretty sure nobody was like in the office my first day. So she was there to like help me guide. She guided me. She set me in Mary Beth's office. I got to roll around in the chair for a while, just waiting to see what I would be doing next. Dawn Stewart, she was the secretary. She talked to me all the time when I didn't have anything to like really do at that time. Alan, he was the like IT guru of the place, so he helped me with like getting my clearance, my computer, so he was great. A special shout out to Robonaut. I got to speak to him whenever I was bored and whenever I couldn't like think straight because I had been working for so long, so I got to go down and talk to that cool guy. And then also like to thank everybody at Lights Program, Wallace Flight Facility, the National Institute of Aeronautics for actually like sponsoring this program. And then government school students, I couldn't stay sane without y'all. The drivers, Matt, Susan, Mr. Austin, all of you, amazing. Becky, amazing. She put me in the perfect position. I would not have wanted to be anywhere else. And then of course, Dr. G, I'll never forget everything that you've done for me. Thank you.
Oh, you bother fair.
Is there any way we can get the camera rotated? That way we can see both sides of the projector.
So you can see both sides of the projector?
Yes, we can stand on either side instead of standing on top of each other.
Yeah, stop. No. Actually, no.